right, well, thank you very much, and welcome to this session. I'm humbled to be here. I'm also a bit scared being the last session of the day. I hope you find it interesting. By the way, I don't know whether you realize our hotel appears in that picture, right? I mean, right there with the yellow strip over there. I was lucky enough to be exactly 1 week ago over that aircraft carrier, the USS Midway, in the Top Gun red carpet, and actually the follow-up premiere also here in San Diego. But well, anyways, very happy to be here. And I wonder about the title, right? I mean, you see, okay, what's in 5G release 17? So let me ask you, does it mean that we already have 17 releases of 5G? Does anybody know? Are we on the 17th release of 5G? No, right? Does anybody know what 3GPP is? I mean, 3GPP, people know, well, I breathe, I live my 25 years at Qualcomm on standards, and I'm basically the standards lead for cellular in Qualcomm, and my life is basically being responsible of 3GPP, which is the body in charge of actually 5G standardization. Release 17 is indeed the third release of 5G. Why it is called, first of all, why it is called 3GPP is legacy, right? It started in the 3G days, it never changed the name again. So it started in, and the first release of 3GPP, by the way, was release 99. Was not even release 1. From 99 went to 4. In release 8, that was 3G days. In release 8, we introduced 4G, and in release 15, we introduced 5G. We are expecting in release 21, roughly, to maybe have 6G starting. But as you can see, release 17 is the third release of 5G, and it really marks kind of the equator of where we are expecting 5G to deliver. John Smee in the morning already talked about 5G Advanced, and now, which starts in release 18. Indeed, release 18 just started. As you can see, there is a little bit of overlap between end of a release and the start of the next one, and we are just about to finish release 17. A couple of notes just to mention is, well, pandemic also hit 3GPP, and despite the fact that we used to travel the world basically, by the way, what is standardization, right? Standardization is companies, is governments, is individuals that basically get together to basically set what is going to be the standard for interoperability of these cellular networks. So the entire release 17 is being done electronically. It's been very, very painful, particularly for those of us in California, because of the time zone difference with the rest of the world. We are on the far west. Of course, for people in China and Japan, Korea, it's equally painful, but on the latter part of the day. Release 16 was indeed frozen in mid-2020, so just about 2 years ago, and we were already in the pandemic. So for 2.5 years, 3GPP has been operating purely electronically. If everything stays the way, we were getting rid of the pandemic, and now we're having a war. But we will be in a couple of weeks in Budapest, in Hungary, for the 3GPP plenaries of June. So let me just move on to the next slide. This is already has been shown, it's been in a few presentations, certainly was there in the presentation from John Smee in the morning. Well, 4G was introduced in release 15. It comes with a lot of the foundations. The foundations are basically what was different from 5G that was not there on 4G, right? One could actually even argue 7 releases of 4G LTE got cramped into the first release of 5G. So it's an extraordinarily complex exercise. And it was also, 5G was designed with 2 things in mind. One is it had to be able to deliver actually diversity of use cases and diversity of spectrum. I mean, Aspa already was talking about the range of actually spectrum that 5G is able to operate on. Not only that, but also we wanted to make sure that it would be forward compatible in the sense that we realized in 4G, maybe too late, that actually the waveforms and the underlying frame structure was not really prone to evolution and basically creating islands of actually enabling basically new technologies or new features to be introduced. And those were actually introduced from day 0 in 5G design. a lot of actually reliance on multiple antennas, and that will be the topic. I think a lot of the topic of today's discussion will basically revolve around that. On sub-6, sub-7, we have massive MIMO. It's interesting to see that everything up to 4G was really mainly FDD bands. In 4G days, LTE TDD really became very, very strong. From 5G, actually most of the new bands are TDD. And in that sense, actually, TDD bands have their own advantages because the same frequency is used for downlink and uplink, then there is a reciprocity that we can exploit, which is really the basis of massive MIMO. At the same time, for millimeter wave type spectrum, what we are relying is on analog beamforming. And the analog beamforming comes together with the necessity of having this, what we call beam management. And beam management was there from release 15, obviously. It's an integral part of millimeter wave design, but has been just improved over the releases. I mean, release 16 added new spectrum, as I already also mentioned, and license was added in release 16. It added missing functionality. So for example, native positioning was not there until release 16. And also sidelink, which is basically enabling device to device in the context of, it was introduced in the context of automotive, so for vehicle-to-vehicle communication, but in later releases is really being expanded to other use cases besides automotive, like public safety, commercial use cases. There is also a fair amount of work on, for example, private networks. And I think we all know what are basically the offerings that 5G brings into that domain. And then another area that is of particular interest is what we call mobile broadband enhancements. I mean, MIMO, like these multi-antenna techniques enhancements, power savings for the terminal, and so on. Now, what comes in release 17, and this is kind of my goal for today, is that you walk away with an idea, okay, release 17 is this standardization that is about to finish, is basically freezing in the next month. What is it that it brings about, right? And here we have 5 actually features that probably are the most notable ones. First of all, going back to Aspa's presentation, the millimeter wave definition of 3GPP up to release 16 included was up to 52 gigahertz, 52.6 gigahertz. In release 17, we go up to 71. So we just grabbed the entire 60 gigahertz band, which is a tremendous amount of spectrum. We also introduced reduced capability NR. It's also been discussed. NR was really brought in as a very, very high-end type of connectivity. People, particularly operators, wanted to really see a difference on the end-user experience going from 4G to 5G. So from 3G to 4G, we went from mandating 1 receive antenna in 3G days to mandating 2 in 4G days. For 5G, we are mandating 4 receive antennas on all the new bands from day 1. And actually, these are the type of requirements. Either you put them on day 1, or then you basically cannot put them because you are deploying the network based on those underlying assumptions. So reduced capabilities introduced in release 17, and we'll talk more about it. Another very important aspect is device enhancements. I mentioned about it, right? More and more antenna, power savings, and there is also a little bit of multi-SIM. I think we had also an earlier presentation. A lot of it can be done by implementation, and Qualcomm has been doing this for a decade. But there are standard-based solutions as well. Not DSDA in release 17 yet, is actually dual standby only. Another very important feature that comes in release 17 is non-terrestrial networks. NTN in 3GPP is basically the motto for satellite communications. This came after 2 full releases of studies and actually came in 2 flavors. I'll also talk about it in 1 second. And then topology expansion, I think we all discussed the importance of actually have ease of deployments. So integrated access at backhaul was introduced in release 16 and only gets improved in release 17 towards a release 18 mobile relay solution. Also, there are other enhancements in topology, for example, enable RF repeaters deployments. Now, let me move into, I think we talked about this. This is effectively bridging and now putting in context a little bit more even this presentation, right? So we do have product announcements in this 5G summit. We had some very nice future research. I mean, people talking about AI, ML, and other things. And what today's or this presentation is about is what the standard today it will define actually, and it's closing next month, right? So it's just the culmination of actually a lot of research that basically went into prototyping and went into the standards, right? I like to tell to my team, right? We are the warriors. I mean, we are warriors in suits, but actually what we are trying to do is driving the technology developed, and which we are part of that development, into the 3GPP for adoption. And actually, Qualcomm doesn't have a free ticket for that push, as you can imagine. So this is what I'm saying. We are closing release 17 just in a few weeks, actually in the June plenaries. We are going to be talking in the rest of the presentation. By the way, I lost the video in the screen on the front of me. If somebody wants to fix it, just a couple of things. We chose a subset of features that we thought it was going to be interesting to talk about. Some of them already were part of those 5 that I mentioned, but they are categorized into either enhancements on the 5G system or actually expansion to different, new types of devices. Now, moving on into a few of these topics. When you talk to mobile operators, I mean, they will say they want to maximize their investments on basically, for example, their towers, right, or the cellular infrastructure. And those cellular infrastructure are just getting more and more complex with a lot of antennas. And if you think about, there is also the fixed wireless access that we've been talking about. This is what this project is about, right? Can I, in the 2 domains that we were talking about, analog beamforming, so the entire beam management, and also the massive MIMO in terms of actual reciprocity for even 8RX devices, can I maximize basically performance? And these are the type of actually enhancements that you see. There is, so SRS it goes for sounding reference signals. This is what is used to and basically invert the channel at the transmitter of the base stations. And basically now we go all the way to 8 antennas. Again, whether we are going to see that on a smartphone, probably not, but for fixed wireless access, it becomes very relevant. Another aspect is, as mentioned, TDD networks. Those are the networks that actually, or a spectrum that enable massive MIMO. And then actually some operators, they started saying, hey, MIMO is now more sophisticated for TDD bands than for FDD bands because you are exploiting all this reciprocity, which is achieved by these sounding reference signals. So can I put some of those learnings back to the FDD, the low bands? And then in that sense, people realized that some of the characteristics, not all, but some of the characteristics of the channel are indeed reciprocal. And this is, for example, on angles and delays, those become reciprocal. And those learnings that we achieved in TDD bands are also getting into FDD bands as well. And then the 4th aspect goes into multi-point. This is a little bit more of an advanced feature where now multiple base stations would actually coordinate with each other. In LTE days, it was called COMP. Now it's called multi-TRP or MTRP. They would coordinate with each other to maximize either reliability, because now you have signals coming from 2 different parts, I mean, so that you have a spatial diversity, or actually improving the overall throughput, right? Because now you have 2 servers instead of 1. Another aspect is uplink. Uplink performance in cellular networks are key. I liked actually this presentation earlier from Mike on this FR2, the myth and all that, millimeter wave myths and realities. And earlier on, we didn't have really uplink millimeter wave. Now we have actually measurements, and it's going very well. But if you talk to operators, they will tell you uplink performance is not on par. And it's not a surprise, and you cannot fight physics, right? So in 3G days, the transmission time was 10 milliseconds. Basically, towards the end of the release of 3G, we had introduced 2 milliseconds, which nobody deployed. LTE was 1 millisecond, so it was a 10x. And now in 5G, for sub-6, the typical one is half a millisecond. And then for millimeter wave, it's 1/8 of a millisecond. So it's another 8x factor. Those basically go with the physics, because you cannot, at least you are a fixed wireless access in a rooftop, right? You cannot really radiate in close proximity of human tissue, basically because there are regulations. You cannot go beyond certain limits. And basically that effectively sets the fundamental limit of uplink coverage, right? You are limited by the total transmit power limit, And then now you are transmitting in these networks at less and less time, right? So you are losing coverage. In order to recover that coverage loss, what you have to do is repeat, right? And then repetitions that were introduced already in release 15 were a little bit too simplistic. I mean, and those get improved, right? Also, for repetitions, we want now to enable the possibility to use memory, right? I mean, on my channel estimation, if I know it's the 8th repetition, I'm going to still try to use channel estimates, for example, from earlier transmissions, right? So these are the type of things for uplink control, uplink data, and even for random access. The third message 3 is the first message that goes into the data channel. It was not repeatable before release 17. So those are very nice improvements. There will be more uplink coverage improvements in actually release 18. Power. Release, I mean, NR was designed with actually green networks in mind. And actually, why? Well, people worried about the two things, right? But energy consumption at the base station, at the infrastructure, and then also ability to create something new down the road, right? So if you always have to transmit some signals, you will never really be able to put something else. So then actually 5G NR was designed with this lean design in mind, so that actually down the road you can put anything, right? I mean, because you are not, the terminals will not get confused and they will basically be set aside those new waveforms or new signals as they are introduced. Release 16 enhanced power consumption for connected mode. And what release 17 does is further enhances this connected mode, but effectively the network will tell the terminal, you can now go to sleep, even in an active data session. Also in idle mode. Idle mode is when you are just waiting for pagings, and just because of this lean structure that I mentioned, the terminal had to wake up to basically get their tracking loops running way in advance of the paging messages because there was nothing else being transmitted elsewhere. So that is actually detrimental in terms of actually power power consumption of NR versus LTE, which actually gets resolved in release 17. Spectrum, I think, already Aspa discussed and I already mentioned. So we finish in 52.6 for FR2. We now extend to 71 in release 17. It's important to realize that there was a temptation to do something completely new and out of the box. But what 3GPP decided, and actually Qualcomm was a big actor for that, is let's leverage as much as we can millimeter wave design from the point of view of actually underlying numerologies. So you allow even the same numerology as millimeter wave or a scale version that would allow you to go to larger bandwidths. And then, of course, let's leverage the entire beam management gear, right, that we already introduced. So we are of the opinion that it's going to be much better performance than, for example, the counterpart 60 gigahertz from IEEE 802.11ad and AY family. Ultra reliability is being one of the anchors of 5G, right? Ultra reliable, low latency communications. It was introduced in release 15. I mean, it was further enhanced in release 16. Time synchronous networks was introduced. And now what we are doing is effectively enabling an improved, for example, coexistence of high priority, effectively low latency services coexisting in the same carrier, in the same channel with regular traffic, right? So, and even in the same device. So there are some prioritizations that in release 16 would actually just drop channels that were low priority. Now we try to multiplex instead of just dropping them. Also time synchronous networks, which of course it goes into synchronizing robots, for example, in a factory. Now we are even having a further refinement of propagation delay, basically compensating for propagation delay. Let me move on to now improvements on topology. They come in two forms. I mean, one is RF repeaters, which is just, Qualcomm really tried to do more than simple RF repeaters. RF repeaters have been there forever, right? I mean, from 2G. In LTE days, in 4G, they were introduced only for FDD bands. But now what 3GPP is doing is introducing them in release 17 for FDD and TDD bands, both, of course, sub-7 as well as millimeter wave. These are, RF repeaters are the preface of a Release 18 project that Qualcomm has really been pushing, which is what we call smart repeaters or network control repeaters, which will actually try to do selective amplification in time and in space. So that actually, the interference that creates the repeater will actually be minimized and actually will only take in the goodies of the repeater. Integrated as a backhaul, it's a bridge between Release 16 introduction to Release 18, which is a mobile relay. Now we have this topology, what we call actually inter-donor migration, which is basically I go from a donor to another one, but not yet to the full mobility. And then we also enable simultaneous transmission and reception, which is a form of full duplex operation. And then going into the second part of the presentation, into expanding to new devices. This is a nice slide, which I like to see in putting in context mobile broadband, which is effectively the smartphone industry. We have introduced this Release 17 reduced capability, which is just taking NR and bringing it down in capability, down to, remember I was mentioning 4RX, 4 receive antennas mandated at the terminal. Now they can go down to 1 or 2, depending on capability. And effectively enables new type of devices. Now surveillance cameras or smartwatches or other types of high-end sensors, right? Now fully integrated into 5G. This kind of segment should not be confused with something that falls really below, which is this LTE family, eMTC and narrowband IoT, which is still the 3GPP proposal for massive MTC, right? NR is really mobile broadband, introduces RedCap, but RedCap doesn't expand the range of regular NR. Narrowband IoT and eMTC were really designed to expand the coverage of regular LTE, and they continue being the 3GPP effectively bet for this massive type communication. From Release 16, they were fully integrated in with 5G core. So you can connect any of these with co-channel with an NR operation in a particular channel, and still both of them connected to 5G core. And then Release 17 NR RedCap will further evolve in Release 18. We will see in what form. People talk about keep bringing down in capability. Of course, we cannot go below 1 receive antenna, but at least maybe in the bandwidth, we will be able to reduce. And then there is some talks that 3GPP starts talking about passive IoT, which is even farther down. You can think about this RFID type devices, passive, no batteries, and still allows some level of intercommunication. So these are basically some of the most salient features of RedCap. I think I discussed for the most part. But you can imagine we are reducing the capability, we're improving power because, for example, even we are exploring the ability to have relaxations on mobility type measurements, which in a particular device could take quite a bit of power. And then we are even introducing the possibility to have a coverage extension by means of sidelink, and I'll talk about that in a second. But first, let me just introduce the 2 satellite projects that are introduced in Release 17. So if somebody asks you, and then this is, what did you learn, right? So Release 17 comes with RedCap, comes with NTN, and comes with enhancements on other things, comes with up to 71 gigahertz, right? Those are really the most salient features of Release 17. Going back to satellite. Satellite, there are 2 projects. One is NR, for an NTN satellite link, for a satellite link. Now, what does it mean? NR was designed, as I said at the very beginning, very flexible because it was introduced for different types of spectrum, different use cases. So actually, it's fair to say that not many changes have been made to enable even this satellite link, covering a satellite link. There are basically some adjustments on some timers. There is an introduction on some bandwidth part, which is a particular definition for basically operating within a particular set of spectrum, and not much more. The next question is what spectrum, right? So what the spectrum that is being introduced in release 17 is an S-band. S-band is something which is very similar to the cellular terrestrial spectrum. So 2.4 gigahertz, so there will be one S-band that will be defined in release 17. With the understanding that release 18 will introduce the other spectrum, the Ka band, which is the most typical for VSAT. The VSAT is effectively this parabolic antenna rooftop type of installation, which effectively it could be yet another form of fixed wireless access with a satellite backhaul, right? For the first type, for this one that even operates in a S-band, which is very similar to cellular, Qualcomm is also being keen on trying to enable low data services, maybe messaging, right? Maybe we are lucky depending on, because there are a lot of dependencies, depending on the satellite geometry, right? Constellation size, distance to, satellite right now, this 3GPP project spans from 500 kilometers satellite orbit to 36,000, right? Which is geostationary. So actually it covers too much. You cannot really make promises, right? Depending on the underlying assumptions, you could even maybe get voice, but if not in release 17, definitely Qualcomm is very keen to support satellite on voice on regular form factors from release 18 onwards. The second project is more, remember this EMTC narrowband IoT I was mentioning that is getting connected to 5G core from release 16. Now it's also being adjusted to basically put them over a satellite link instead of a terrestrial cellular link over a satellite link. For similar reasons, very few changes were really required, and actually this is going to be a project. Indeed, it's going to be delivered in release 17 as well, opening up a whole new myriad of actually opportunities and use cases that maybe before you could not do with all types of asset tracking, right? Even across oceans. Sidelink. Sidelink was introduced in release 16 and is, as you know, is the ability for a device to connect with another device without a network behind. Actually, 3GPP is always trying to be also inclusive. The network can or cannot be, may or may not be. So in the presence of a network and in the absence of the network. So both of those use cases are contemplated. In release 16, it was developed primarily for automotive, as I mentioned, for this V2X, so vehicle to vehicle, vehicle to infrastructure. And in release 17, it gets actually upgraded, particularly with power savings. Because if you want to put basically a V2X module in a smartphone, battery is a key, right? So you cannot basically go with a drain that would enable, basically, it would render that particular feature useless, right? So this is the main aspect that I think release 17 Sidelink introduces is power savings on the Sidelink. Also, there are some other enhancements in resource allocation, also not only helping in power, but also helping in reliability on the connection. There are some new frequency bands, and there is another project that introduces the ability I mentioned about coverage extension by Sidelink, right? So now imagine I have a phone, and I have coverage, and I want to give coverage to Yongbin, right? He doesn't have coverage, so can I basically take the personality of a relay, right, for Yongbin, and basically I'm relaying Yongbin's information through the network via myself. So effectively, this, what we call UE to network relay, is introduced in release 17 as well. And there are two protocol solutions for this. Again, there was a lot of different views, very, very contradicting, very controversial, layer 2 and layer 3. So layer 3, the beauty is that there is control from the basic infrastructure. The layer 2 remains more locally, right, between the acting UEs or terminals. And then positioning. You wonder, why is positioning such a hard problem? So actually, when I was thinking of how I'm going to introduce, and we're not going to read all these, but I was just trying to think of what are the things I can basically tell you so that you walk away and then you have a good idea. Positioning is about distance, measuring time, and time is directly proportional to distance. And then actually, if I know the time that it takes to go from one place to another, I can just draw a circle. And then basically, if I draw different circles, I have intersections, and basically I can just put the time or the position where I am. If I use time differences, I don't draw circles. I don't draw circles, I draw hyperbolas. And effectively, it's all about time measurements and angle measurements. So it just turns out 1 degree error after 60 meters, it's already 1 full meter of error. So if you target centimeter level type accuracy, imagine what is the degrees of error that you are able to accommodate. Likewise, if you basically just move 1 meter from the position you are 1 meter, your positioning, your timing, and basically propagation just changes by 3.3 nanoseconds. So just gives you the idea, the sheer order of magnitude of the complexity of the problem to get down to centimeter level positioning. And this is what release 17 tries to do. So there are these enhancements on accuracy, getting this centimeter level by just playing. Indeed, it's indeed preparing for this AI/ML type method that may come in release 19 and are being studied in release 18. And then it's also reducing protocol delays in terms of actually triggering positioning measures and actually improving efficiency by enabling, for example, these on-demand position reference signals and introducing this GNSS, which is the GPS, the satellite assistance for integrity determination. So you don't want to be effectively rogged with a particular positioning measurement. Last slide we got is XR. XR is, believe it or not, I mean, 5G was designed for XR, but 3GPP didn't really have a traffic model or even a set of requirements that different XR applications, and you know, XR is very rich, right? It can be augmented reality, it can be virtual reality, mixed reality, and this is what this project achieved, is effectively creating consciousness of what is this. 20 years ago, we did the same for voice, by the way. And then actually data, I mean, voice activity, this on and off inactivities factors and burst duration and so on. Now all this came for XR applications. I would say now 3GPP is fully equipped to tailor-make improvements for XR deployments when they become a mainstream, starting probably in release 18 timeframe. And with that, I'd like to thank you all, and I hope you can walk away with a few things from release 17. Thank you.